2x cubed minus 5x. So here is our function. We're interested in looking at this function when a is equal to 2. And so here is our a value is 2. That's an x value. So when x is equal to 2, here we're looking and we look up at our function. Now, this seems really unfocused. This is not okay. Got it. All right, so we really want to focus around where x is equal to 2. So I'm going to change my window a little bit here. And I'm going to look at x values between 0 and 3. And y values, I'm going to extend y minimum of negative 10 and a y maximum of 20. And so here's a zoomed in picture of our function. And when I look at this picture here, if I type the trace function, and I type in x equal to 2, the y value that I get out is 6, which makes sense. That's what we got when we plugged 2 into our formula. So here's our point right here. Now, what I'd like you to do is to sketch a picture of this function on your paper. Maybe in the margin. It's not really, it's not that a huge important part of your notes right now. But sketch a picture of this function. Mark the point 2, 6 on your paper. And in addition, sketch a picture of a straight line that just kisses the curve at the point 2, 6. So it comes up here, should come right up here, just kiss the curve, and then just bounce off. And that will be your tangent line at 2, 6. Now hold on to that picture because we're going to come back and compare it once we come up with our final answer.
A line under it?
And so you would expect it to be a line underneath, very similar to this picture here, the way our purple line is drawn. Okay, so our goal is to calculate the slope. We have a point, but we need the slope. So right now, our slope is going to be given by f prime of 2. The slope of our tangent line at a is equal to 2. That's f prime of 2. Now, in terms of our definition over there, that means that we're looking at the limit as x approaches a, well, in this case, a is 2. The limit as x approaches 2, of f of x minus f of a, but our a is 2, all over x minus a, but a is 2 in our case. So the limit as x approaches 2 of f of x minus f of 2 over x minus 2. All right, so we've now written down an expression to describe slope. We haven't actually calculated the slope yet, but are there any questions on writing that part down? Okay. In that case, let's start to fill in some values. F of 2, well, that says I look at my function and everywhere I see an x, I replace it with a 2. Now, we've already done that because we figured out our y value already. So that's a value of 6, and we got that by 2 times 2 cubed minus 5 times 2. That gave us 6. And f of x, well, that is specifically our formula. So that is 2x cubed minus 5 times x. All right, so when I fill in these pieces of information, I've got the limit as x approaches 2 of 2x cubed minus 5x minus 6 all over x minus 2. All right. Are there any questions on the information that I've filled into this expression here? Okay, so now we've got ourselves a numerator, a denominator, and a limit. And the question is, what is the limit of this expression? Okay, so we want to solve this limit. So if this problem, if you were walking down the street and somebody just threw this expression at you and said, here, solve this limit, you know, honestly, you're just walking right down the street. The very first thing that you might do is say, okay, if I need to solve this limit, what should I do? So the first thing you might want to do is to check to see what happens if you plug in the limiting x value. And so as a side note over here, a little thought bubble, if I plug in 2, I have 2 times 2 cubed minus 5 times 2 minus 6 in my numerator, which gives us 6 minus the extra 6 there gives us 0. And in the denominator, we have 2 minus 2, which gives us 0. And so if I just plug in my limiting x value, I end up with 0 over 0. What does that tell us about our next step?
Use algebra.
Yeah, we're going to want to use some algebra. We've got a hole in the graph that we're interested in. And so we've got to use algebra to get rid of that hole. Alright, so we want to use some algebra, and that means that our denominator, there's nothing we can do with that, that's just x minus 2, but our numerator, we might be able to factor that thing. Alright, so factoring that numerator, if I look more closely at that numerator, if I rewrite this over here, I've got the limit as x approaches 2 of 2x cubed minus 5x minus 6 over x minus 2, and I stand back and I say, okay, how am I going to factor that numerator? And I look at it, and I kind of start to sweat, and I start to get a little nervous, because what I have in that numerator is a power higher than 2, and I know how to factor quadratic stuff, you know, pretty readily, but anything bigger than a quadratic is not necessarily an easy polynomial to factor. And so here's where some college algebra comes into play. What we've got here is we want to think of a way to factor this numerator. Now, we have it, one thing that we do know is that because we ended up with 0 over 0, that meant that one of our factors in the numerator is matching a factor in the denominator. So one of our factors is x minus 2. And so if we want to continue to factor, one way that we can do that is through long division. So I can take a look at figuring out how to factor. So to factor 2x cubed minus 5x minus 6,
Better go back.
we know that x minus 2 is one of our factors.
Back.
So we can use long division to find the other. Alright, so if you haven't used polynomial long division in a while, or if you've never seen it, if you happen to skip over it at some point, this is going to be a good reminder / quick tutorial of polynomial long division. So how do we set this up? Well, I put my division sign, and I've got my x minus 2 on the outside. We're going to divide x minus 2 into the 2x cubed minus 5x minus 6. So I've got 2x cubed minus 5x minus 6. And so I ask myself, what do I need to multiply x by to get 2x cubed? Yeah, and I need to multiply by 2x squared. So I've got 2x squared times x gives me 2x cubed. And my 2x squared times negative 2 gives me negative 4x squared. And I'm going to subtract this piece from what I have above it. So when I do this subtraction, I'm going to distribute this negative sign to both pieces. And so now I've got 4x squared minus 5x minus 6. Are there any questions about what I just did right here? Okay. So now I want to keep going. And so now I ask myself, what do I need to multiply x by to get 4x squared? And it's going to be 4x. So I add on a plus 4x on the top here and multiply 4x times x, and we get 4x squared. And 4x times negative 2 gives us negative 8x. And now we subtract that portion off, and we can distribute the negative sign. And so our 4x squareds cancel. We're left with positive 3x minus 6. And we're still not done yet. Our powers are still the same, so I've got one more step here. I need to multiply x by 3. So I've got 3 times x is 3x, and 3 times negative 2 is negative 6. And so we end up with a remainder of 0. And so what this long division did for us, and we'd better end up with a remainder of 0 because we're claiming that we can divide out an x minus 2. Okay? If you don't get a remainder of 0, something went wrong. What this tells us is that 2x cubed minus 5x minus 6 can be factored into x minus 2 times 2x squared plus 4x plus 3. All right, so that right there was some algebra from the past. Are there any questions about what we just did there? If we had been lucky, our example would not have been this hard to factor, but in this case, we had some hard work to do with our factoring. Okay, so now let's go back to our limit, and we've got the limit as x approaches 2 of x minus 2 times 2x squared plus 4x plus 3, all divided by x minus 2. So all of that long division was literally just to factor that numerator. But the thing is, once we've done that, then I look at this and I'm ready to celebrate, right? Because now I've got an x minus 2 in the numerator and the denominator, and they can cancel each other. And we're left with the limit as x approaches 2 of 2x squared plus 4x plus 3. And now I'm psyched, because I no longer have a denominator to deal with. And this tells me that I can now plug in my value for x. So remember, at one point when we were using all those limit laws, we distributed the limit symbol, pulled the 2 out in front. But in the end, once we have a polynomial, or once we have a rational function where the denominator is not equal to 0, the function we have left is continuous, and we can just plug in our x value. And so in this case, what we have here is 2 times 2 squared plus 4 times 2 plus 3. All right, so we've got 8 plus 8 plus 3 for a total of 19. Whew. Okay, so that 19 that we just came up with right there. Okay, what we did to get that 19 is we calculated the slope of the tangent line at a equals 2. In other words, we calculated f prime of 2. And that number at the end there, that 19, is the slope of that tangent line. It tells us how steep our function is when a is equal to 2. So all of that work told us that the slope for our line is 19. All right, so our goal was to find the equation of the tangent line to this particular function at a equals 2. We now have a point, we have a slope, we can write down the equation of our line. So our point is 2, 6, and our slope is 19. So use your favorite version of the equation of a line. I'm going to use the point slope form. If you prefer the slope intercept, that's fine also. So we have y minus 6 is equal to 19 times x minus 2. And then we can simplify this. So we've got y minus 6 is equal to 19x minus 38. And add 6 to both sides. And so we've got y is equal to 19x minus 32. All right, so this is the equation of our tangent line. So what I'd like you to do now is go back to your calculator where you had a picture of the original function. And I'd like you to graph as a second function, a second picture on there, y is equal to 19x minus 32.